Hello, all, and welcome to this new QWave session. This is our fifth episode, and today we'll have Hiro Nakata from GIJ talking about the Japan's quantum landscape and the Euro-Japan collaboration. Uh, Before jumping in the actual QuickWave series and the session, I would like to introduce a little bit about QuIC for those who doesn't know us. So QuIC is a non-profit association established back in 2021, sorry. The mission is to strengthen the quantum technology industry with a big focus in the industry and position Europe as a global leader on the sector. For doing that, we liaise and we have a lot of members, roughly 200, and we have several working groups in which we do different activities, do with papers and make all of these things. I also, well, you have a QR code to our website, just in case you don't know it. There we publish everything since the events that we are doing and also the white papers and the recommendations. Everything is there. Also, for those who doesn't know, we have Q Expo. Q Expo is a 2-day expo that we have and QuIC is hosting. You have the website qexpo.org and also the QR code. So this is on the 14th and 15th of May in Amsterdam, and the first day will be an industry exhibit with booths and companies showcase themselves, and the second day is going to be a plenary day with international speakers. So it's a free event, so I hope to see many of those that are here in this session there too, so we can connect live and in person. With that said, let's introduce our session and our speaker. So, as I was saying, today's session will be held by Kata from GAJ. GAJ is a member of QuIC and also from Q-STAR, the Japanese Quantum Industry Consortium. And he's going to provide an overview on the quantum landscape in Japan and explain specific examples of collaboration. Also, we will talk about the different stakeholders and strategy within Japan, the major events, and some examples between the collaboration and also use cases. So let me introduce Hiro in the session. So Hiro is the Chief Operation Officer and board member of GIJ. That is a Tokyo-based startup. So they are spreading the development of this SEPT that I hope that he talks more about. That is a revolutionary cloud-based operating system for quantum computing hardware. Prior to join GIJ, he has a stellar career in the energy and utility infrastructure sector, and his portfolio includes pivotal roles in business development in project finance, and he has an M&A for an area of projects across the globe, especially in Australia, Brazil, and Mexico. So here we have Hiro. How are you?
Hi, good, thanks. How are you?
Very good. So I encourage you to share your screen so we can all see that wonderful things that you have to talk us about, like the use cases, the Japan ecosystem, stakeholders, and everything that I'm personally really interested in, and I hope that our viewers are also interested in.
Yeah, thank you for your introduction, David. So yeah, let me show my presentation.
While
So
Hiro is sharing, I want to encourage you to use the chat to write questions, so we will answer those questions at the end.
okay,
So.
thank you. Okay, so okay, so it's okay. So today, so I will explain about the Japanese quantum landscape and EU-Japan collaboration. My understanding is that the QuIC member is the 200, and the from outside of the Euro, there are like several company joining, especially from Japan, the Toshiba and our JIJ joining this QuIC. So in this time, so it's a very good opportunity to explain the landscape of the Japanese quantum ecosystem, and then it's how to like collaborate each other. Today I will explain. So the agenda is that, so my introduction and then the key stakeholders and strategy. So first one is our JIJ's overview, and the Q-STAR. Q-STAR is the Japan Quantum Ecosystem, Quantum Consortium. And then so government overview. So it's including a GQuAD. GQuAD is Japanese National Quantum Computing Center. And the next one is that, so in the next several months, Japan has some a very key event for quantum. And I'll show to you is that, so is very specific collaboration between EU and Japan. And the last one is that, so the JIJ has developed the 40 quantum use cases. I will explain in the detail. So as the David explained, but let me briefly explain my background. So I had my career. I started my career in the Mitsui. Mitsui is one of the global investment company. So it's focused the business development and project finance for the infrastructure business in the Mexico and Brazil and Australia. So I dispatched in the Melbourne in Australia in the 2 years, and then so I joined the JIJ. So this is the brief overview of the JIJ. So JIJ has the branch in the Tokyo country. So I'm in the Tokyo. So Tokyo is like 10 p.m. And then so we have the branch in the London in the UK. So in this year, so JIJ plan to have the established a branch in the Hamburg in Germany. And we are member of the of course the QuIC and the Q-STAR. And last month we joined the UK Quantum. So our staff is almost 44. So what we do is that we focus in the optimization. We try to solve the large scale type of the optimization problem using quantum and quantum inspired machine and HPC. So JIJ is from this mathematical formula. So this showed the Isaac model. So maybe the physics background people knows well. So but so our company is from the university. It's called the Tokyo Institute of Technology in Japan, and our CEO is from the laboratory of the Mr. Nishimori, who discovered the algorithm of the quantum annealing. That's why our company is called. It's from the JIJ, the Isaac model. Yeah, so this is a management team. So our CEO and CTO is from the Nishimori laboratory. And then, so I joined the JIJ in the 3 years ago. So we provide a product in the UK, Germany, Singapore, Japan, the US, Brazil. And we provide our OSS. It's downloaded almost the 1.8 million. So as I explained, so we joined not only the QuIC, the Q-STAR Japanese Quantum Consortium, and UK Quantum. So we provide the optimization solution. So we provide the software. It's called the JIJ Zept, and the JIJ connect to the IBM Quantum, Orca, Aquila, OQC, the type of the quantum computers, and DA, and the quantum inspired machines, and it's like classical the optimization solvers. So I've explained later. So we have the Japanese the government project. It's called the SIP and Bridge and NEDO. So actually, so I made the stakeholder map. So this map is what I'd like to explain that today. So Japan, the stakeholder try to achieve the industrialization. This is a very important the term, and the Q-STAR is, of course, it's one of the most important the stakeholder in Japan. So they are the industrial consortium. So their the member is 108 companies, and then especially is that there are 56 end user companies in the Q-STAR. So they develop the almost 50 use cases in the energy, the electricity, the manufacturing, the traffic materials. So the Japan is like the heaven of the use case development, and then so QSA try to like export the knowledge of the use case development. And also the government body point of view, there are three key the organization. The first one is METI. METI is Ministry of Economy, Trade, and Industry, and the Cabinet Office, and the Ministry of Education, Culture, Sports, Science, and Technology. It's called the MEXT. So the METI is more like an economic side in the business side, and then the MEX is more like the scientists and academia side. And then the Cabinet Office is established in 2002. And the very unique thing is that so they have the many secondaries from the METI and MEX, and they have they make the national quantum strategies. And the METI, the big news is that so METI has the several the values and the called innovation development policy value. They invest almost the 633 million for the new fund. So they got in the last October. So for 2025 and to 2027 to the NEDO. NEDO is the funding agency, the New Energy and Industry Technology Development Organization. Also, OIST also is the Research and Innovation Center in Japan. So OIST has the National Quantum Computing Center. It's called the GQuad. GQuad is the Global Research and Development Center for Business Quantum AI Technology. So they are almost complete their facility like this. And so they will have the opening ceremony and in this May. And the Cabinet Office has the several quantum program. It's called the SIP and the Bridge Moonshot. It's a bit different, but anyway, it's like a quantum programs. And MEX has it's one of the biggest research center. It's called the RIKEN. And RIKEN operate the quantum innovation hub. It's called the QIH. QIH is like several the Japanese quantum innovation hub, like Osaka research center and the OIST, QI and NICT. It's like Osaka. It's like Okinawa Prefecture University, and some sort of the quantum ecosystems in the QSA is operated by the RIKEN. So this is the overview of the Japanese stakeholders ecosystem. The QSA is the collaboration so with many end users, and they develop many the use cases. Also, the METI is investing in new funding to the funding agency and OIST. And OIST has the GQuad. GQuad will open their facilities soon. Also, on the cabinet office, they made the several national quantum strategy. Also, they have the quantum programs. And then finally, some MEX is leading the development of the science and academic, and RIKEN is operated by and the QIH is the Quantum Innovation Hub. So this is a very like a brief the overview of the Japan stakeholders maps. Okay, so let me explain more about the Q-STAR. So QuIC is from the Quantum Strategic Industrial Alliance for Revolution in Japan. So they established the 2021, and their membership 108. So our GIJ is one of the member of the QSTAR. So so they cover the materials, the quantum materials, quantum life, not only the quantum computers, but also like QKD and quantum centers and so on. So on the first at the beginning, so they had only the 11 members, but in the currently they get the 108 members. And so so they have like including the 56 end users. This is a very unique point. And so in the 2023, the QSA had the strong relationship with the QuIC and the QEDC and the Canada's quantum industries, Canada. So it's called the International Council of the Quantum Industry Associations. From the collaboration, QSTA start the collaboration with the QuIC. And then QSTA is also seeking the opportunity for the mutual understanding with the Germany and US and the QuIC and the Korea and the UK and the Canada and Australia's the consortiums. So this is their activity. So ours are the QSTA staff. So they has some exhibition in the next and the Q Expo. It's held in the May. Okay, so back into the GQuad. GQuad is the GQuad is here. So it's the National Quantum Computing Center in Japan. So I will explain briefly about the GQuad. So GQuad has the allotted budget from the Japanese government, and 2022 and 2023, and then new one is that 2024 they get. So they have the several facilities. The first one is that they have the NVIDIA's HPC. Also, they have the QERA and the Fujitsu and the OptoQCs, the quantum computers. Also, they have the several quantum inspired machines. So it's planned to open in the end of this March, and then they sooner or later they will open in the May. So this is the organization of the GQuad. So they have the several the functions, and then so the Teribota is the board member of the GQuad. So he's like international advisory board of the GQuad. So GQuad has the collaboration such as the NIST and the Canadian organization and the Korean organization and the key site IBM QERA. So they are very aggressive to has the collaboration. So they are very open to collaborate with the European organization, especially the hardware companies. So if anyone is very interested to have the collaboration with GQuad, so I will contact them. So yeah, please let me know. Okay, so the key future event is held in the Japan for the quantum, especially it's held in the May. So on the early May, so GQuad has the opening ceremony. And the QTB Tokyo, it's very unfortunately, so it's almost same time in the Q Expo, but it's held in the 15th to the 16th in May. And the end of May, the JTC3 is held in the Japan. JTC3 is the quantum industry, a quantum standardization committee. It's arranged by the IC and ISO. It was established in the 2024. The first one is held in the Korea, and the last one is held in the Edinburgh in UK in the last October. So after the discussion, so it's finally decided to held in the Japan in the end of May. And the last one is that the Quantum Innovation 2025 is arranged by the RIKEN. It's held in the end of July to the beginning of August. And then the Osaka Expo, it's like a world expo. It's held in Osaka. Osaka is the west of Japan. So many countries, they have like exhibition in the expo. And then Japanese quantum and the players, they have like exhibition in there. So next one is that EU Japan collaboration. I will explain. So this is the Japan EU digital partnership. It's executed in the 2022. So this is like a digital partnership between the Japan and EU. So it's for the like many different types of the function, like skills, the public service, business infrastructure. So based on the partnership, so this is a new call. It's already closed, but it's published in the last November. So it's called the European High Performance Computing Joint Undertaking. So the consortium, the Euro consortium, need to join this bid with the Japanese quantum consortium. They have the quantum project in Japan. It's called SIP. So this is like a mandatory requirement. So on the consortiums in the EU, they had the long discussion with the several players in the Japan who had the project of the SIP. So it's already open. So, but the several is not open yet. But so the sort of the collaboration opportunity between the EU and Japan. So we have. So the sort of the project, it's a very good opportunity to collaborate each other. So last one is that, so I will explain the quantum optimization use cases. So I think the most of you know what is the optimization, but let me explain in here. So there are like many industry problems in the like energy, the utility, and manufacturing, the construction, and the telecommunication, whatever. So the it's need to like select the optimal solution from the such the large scales, the combination, and then to achieve the maximizing the profit or the minimizing cost. So it's affect a lot of impact. This is what we try. So our solution is that so not only the quantum computers but also the algorithm, the mathematical optimization, and then using the HPC and the generative AI, they contribute a lot to the solve the problems for the large type of the scale, large scale type of the problems. So in the JIJ, we already had almost 40 use cases in the energy, electricity, railway, security, construction, manufacturing, finance, traffic, material, and telecoms. So like in the energy, like a power, a supply demand, oil terminal inventory management, a route optimized for petrol operations, something like that. Also, the manufacturing is the production planning and material efficiency for the glass cutting optimization. The construction was that the black box optimized for rubber structures, prediction for the physical properties. The railway is that operation planning for the conventional railway lines. Some sort of the many use cases we already explained. So it's this the example is very the unique is that. So the JNC is the very famous the chemical company in Japan. So they had the plant to make their uh, product. So it's their component is from over the 100, and they have some like a three assembly line. So the facility guy, so in the day they need to take the 6 hours, but if so they use our product, it's called the JJZEP. It's the automatically the software forward optimization, so they can achieve to reduce to the 1 minutes. They dramatically reduce their the time. So unique thing is that so it's already is installed in the real business use cases. So it's not just only for the R&D. So this has the real impact of the business. This is a very unique thing. So on our JJZept is the platform for to solve the optimization problems. So so this is our definition of the developer's experience of the optimization. So it's we call the 30 optimization success. It's from the 1 to the 30. So there are some a lot of um, the the process they need to do to achieve the optimization success. For example, so to sort it out their constraints, so they need to make the mathematical modeling. So they use some solver or the quantum computers, so they get the like output, and then so they need to like visualizing their output, and then so they back to the first make the mathematical modeling to using the solvers or the quantum computers, something like that. So they repeat. So what do we think is that? So the optimization for the industrialization, we need to do the 30s activities. But just only using the quantum computer is only here for our point of view. That's why. So, and our JSF to achieve their the optimized success through the using the software. This is what we try to do. Yep. Okay, David. So this is my the brief explanation. So yep, I just finished.
So thank you so much for your wonderful presentation about the landscape. It has been really good to understand how Japan's ecosystem is working and the different stakeholders that you have, the different events, the national strategies, and all of that. So really, really good. Also to understand how JAG is doing so with this operating system and also the use cases. So uh, as I said, really, really good. I want to
Thank you.
remind the people who is watching us that there is a chat on the right, so they can use that chat to ask any questions that they have. While we get some of those questions, let me ask you some questions that I have
Yep.
here that I believe it could be interesting to know. So one of the questions, Thierry just write a question, so I'm gonna go for his first. So
Mhm.
Hiro, in your view, what are some of the main difference between end users in Europe versus the ones in Japan?
Okay. So it's my view, but so Japanese company, so their end users has the R&D team, and R&D team has the like a independent budget. So someone has the huge, someone is small, but so they have the independent budget. That's why. So they are very easily to start like their projects. So this is a very, I think it's a good thing for the Japanese the end users.
Cool, thank you. So let me get the Q&A running. So the question I had for you,
Yep.
like, I really like the approach of like actual having use cases to solve problems. So you were telling in your presentation that you have around 40 use cases. So
Yep.
among those 40 quantum use cases developed at GAG, which ones are particularly close to the commercialization to actually get to those end users that, for example, Thierry was talking about, or expect, in the other hand, to have a major market impact?
Okay, so our focus is that the energy and manufacturing for the industrialization. For example, we had the experience to reduce the annual cost of the per plant company. So their annual cost is it's like almost like 40 billion euro in the year. It's such a huge. But if so, they use our optimized algorithm, they can achieve to reduce the several percentage. But so the basement is such a huge. So if they reduce just the several percentage, they can achieve to reduce a lot. Also, the manufacturing, so they have a lot of problems. But they are not only JJ, but also some Japanese players. So we install the solution in their real business. That's why we think the electricity and manufacturing is a very good opportunity to install the business situation.
Okay, cool. So I know that in this webinar we are talking about Japan in particular, but related to these questions, do you think that on the overall landscape like in the world. This is also the case, like the manufacturing and the energy part, or it's something related more to the Japanese ecosystem, and outside there are other industries that are more impacted.
Yeah, so definitely different. So of course, it's not only Japan, but also of course in the Europe has there are a lot of problem with the electricity and the manufacturing. So the Japanese players, including the JJ, so we have the some like experience for the quantum inspired machines, and so we have some experience of the using the algorithm for the large scale type of programs. So of course the quantum computers has some the just adapt only the small the scale of the problems currently. That's why some like hybrid approach is important. And yeah, so we can adapt to the problems of the Europe, of course.
Yeah, yeah, I can understand that. So, related to the like the higher part of like the whole world or Europe, quick recently, like a month or so ago, quick release this white paper about the IP patent landscape,
Yeah.
like comparing the patents within Europe to Japanese or the States or many other countries. So, but we are not talking about the patents. So, regarding the IP itself, so in the
Mm,
past years, what policies or events have influenced the advancement of these quantum technologies?
mm.
Uh, Mainly in Japan, because in this talk we are talking about Japan. But if you can name some initiatives or some IP regulation that you feel that they have already helped.
Actually, so on the strategy point of view, the Europe is more like a developed and strict the IT patent strategy more than Japan. So also on the Japan's weakness is that we have the few hardware companies. The Europe has a lot of the hardware the providers. Yeah. So this is my opinion. That's why we need to develop the use cases. Yeah.
Yeah, like we within QuIC, we think the same. This is why we have this working group about use cases, because we feel it's really important. And talking about use cases, the end users, the industry, the government, like we have a lot of different players and stakeholders. And I want also to asking to the viewers that if they want to comment or ask, they have the chat. But anyways, talking about all of this ecosystem, you show in one of your slides all the players and where are they taking part in and how they collaborate, or the collaboration that they have. So, what what do you think that are the key players? Even given that you have some show some of them, what do you think that are the key players? If you can share what are the strategy that you think they are having, or the strategy that JJ is having with all of these private companies, the government, the academic institutions, the research centers.
Okay, yeah. So, the first of all, the uniqueness of the Japanese ecosystem, it's not only for the quantum, it's in general, but uh, it's a good thing, it's a bad thing. But if the new prime minister is selected, um, so it's not dramatically change. So on the like Europe and the US, if they change their party, so their policies are dramatically change sometimes. But the Japan is it's always stable. It's a good or bad. So that's why the government and the consortium and the private company and the research center they are working closely. So this is the one of the topic. And so if so, we have some like a partnership that we have the business. So JIJ has some the business or the partnership in the Europe. So actually, so what I important thing is that so the not only the like companies partnership, but also like if so QuIC Q-STAR have some like a strategic relationship. Also, the Japan, the government, and the European government, they each collaborate a lot based on their like specific strategy. The sort of like a several layers, the collaboration at the same time is very important.
Okay, and building on that, you are talking about the collaboration between Europe and Japan. I believe I'm going to ask a question that actually is more than one question. So,
Right.
first of all, so we have this kind of collaboration, and you have so that. So, in the first question is, what do you think are the most promising or most impactful projects of the collaboration? And on the other hand, what are the biggest challenges for that? Because even though we are collaborating, I guess there are some challenges. How do you see both things?
Okay, so on the so I know the several like opportunity to collaborate between the EU and Japan. So the in the what I explained is that the Euro HPC had the bid. It's their money is from the EU, but the so Japan has some like sometimes they funding so for the collaboration between the EU and Japan. So the I know the Germany Japan collaborations funding it's paid by on the Max in the last year some sort of opportunity we have and then so the hardest the biggest hardness is that some like the data policy is sometimes different between the Japan and EU. And then so and the EU has the very strict the policy for the using the data or like OSS. So some sort of the Japanese people need to understand the properly it's the strategy of the data policy in the EU. Yeah, this is yeah we need to try to do that.
Okay, so tackling about more future. So now we have talked about the collaboration. When
Yeah.
we have those kind of agreements, how do you see like in the near future that once we have closed and these agreements are the programs, how do you
Yeah.
see the I don't know if it's suitable to talk about commercialization of the things that we are building, but how do you see the projects in the near future?
Yeah. So the for example, also I know so the QuIC member there are a lot of the hardware companies. Also on Japan, the QSTA has the many end users. So it's very like so if the boss is interest, it's a very good opportunity to have some like the workshop and then the QX, the hardware's companies, they give the opportunity to use their hardwares to the end users in Japan. And then the end users from Japan, they provide their experience use case to the hardware's company in the EU. Some sort of collaboration is in near future. It's good to start, I think.
Okay, so tackling not all on also the future. Uh, as Hiro has already said, we have an agreement through the International Council of Industry Association. So I want to ask you about how this collaboration or how Q-STAR is contributing to the growth of the quantum ecosystem, because in focusing in industry, because as you know, QuIC is the voice of the industry about quantum technologies within Europe. So how is Q-STAR doing that?
Yeah. So on the yeah, so on the QStar, so they have some like a working group, especially the use cases and then so optimization. So QStar say the optimization is one of the strongest point. Some software knowledge, so we are very ready country. So the most of the knowledge is written in Japanese, but so we are very like uh, it's to change to prepare some sort of English and the materials. It's prepared by the working group. Yeah, some sort of the knowledge we are ready to share.
Yeah. So yeah, in order to have this bigger impact, yeah, maybe it's one of things that you can tell. Um, I don't see any more questions in the chat, so if there is no more questions, I will ask you, I believe, one final question, so you can like wrap up and have a summary of everything before we can close. So, in your opinion, what do you think that? Well, I'm gonna ask about Japan, but you can give the bigger picture. How do you think that Japan will or should prioritize the strategic autonomy in the quantum tech um, towards more international agreements, that the one that you are talking about and the EU agreement that we have, or using more about the research centers that you have, or how do you see, more than choosing one or other, how do you see this collaboration becoming together in order to strengthen the Japan ecosystem?
Yeah, it's a very good question. So, uh, actually, so on the QSTA and the METI and the GQuad OS, we talk almost every day. But so our strongest point is that two things. One is that like use case development. The second thing is that like global the supply chain. So the Japan has a lot of the vendors who provide the equipment of the hardwares, the quantum computers hardwares. So this is the it's like a two the main like elements for the strengthen of the Japanese the quantum the strategy. Yeah, based on that, so we collaborate. Of course, it's mainly in the EU, and yeah, so we need to make some solution together.
Yeah. So as I don't see any more questions, I totally agree with you that the collaboration should exist, and we have to keep pushing that because it's the way that the world is growing right now, and I think it's really important. With that last word from Hiro, I want to like thank you, Hiro, first to be here to showcase the Japanese ecosystems and to talk about the different stakeholders and the use cases. Also, thank the people that is watching this webinar through YouTube. I encourage you, and I'm gonna get this slide to follow us on LinkedIn. Follow also GHJs, and also visit our YouTube channel, the one that is hosting this series, because the recordings and the streamings of the past QWaves events and are there, so you can rewatch them. Also, like the videos, it really helps, and also subscribe to the YouTube channels because it helps us to grow and to bring new QWave events. And last but not least, because the day is getting close, again, I want to remind you that Q Expo is going to be on the 14th and 15th of May in Amsterdam, and I'm also gonna paste the website in the chat. So again, Thank you all. Thank you for your insightful comments, Hiro. I believe it really helps the ecosystem and the relation between Japan and EU. Thank you all and have a good day. Bye.
Thank you for arrangement. Thank you.